I'm Pat Topolinski. Thanks for watching. We know you never want to miss an episode of Engine Power, so click the subscribe button, and there you go. It's the big subscribe button right there.
Today, it's high performance history as we revisit some of our favorite iconic engine builds. Aside from building big performance power plants, we love to pay tribute to the engines that not only have personality, but plenty of history as well.
And what better way than to revisit some of the vintage iron that we have had the pleasure to revive and give new life, and some more power.
Legendary for being indestructible, today we're going to dissect, rebuild, and hop up a true American cult engine, the bulletproof Chrysler Slant-Six. Why, you may ask? Well, it's a popular engine several of you viewers have been asking us to go through. Its revolutionary inline-six design is tilted 30 degrees off-center to allow a lower hood profile, a lower center of gravity, and more access to engine accessories.
We picked this one up at the local boneyard for $150, and while it's not going to perform like a V8, this leaning tower of power is high in the cool department. But I think it has some issues.
Unfortunately, ours sat out in the elements and heavy corrosion kept us from reusing it. So we started with a later model block and had it freshly machined. Now the crank was installed with an upgraded one-piece rear main seal, and reconditioned rods were dropped through the bores with new pistons attached. A completely refreshed cylinder head was dropped on the deck, and the engine was finished off with performance parts from Hooker, Offenhauser, and Edelbrock. We couldn't dyno our Slant-Six because the bell housing diameter is too small and it wouldn't dock up to the dyno, but we told you we had a home for it, and it doesn't get any better than this 71 Duster.
When it's cold, it spits, it sputters, I gotta warm it up, it's got an exhaust leak, so it just makes a lot of racket.
And here's its owner, Ken Symington, who has an emotional attachment to this work in progress.
You know, this car is over 40 years old. There's not that many of them out there running. Mainly since my wife bought it brand new. When I first met her, she was blonde, she was cute. Then the next time I saw her, she showed up in this red car, and the red car and the blonde hair went together, and I knew right then I was in trouble. She loved it. It was her first car. She might love it more than she does me. I've never asked that question to her.
This is actually more fun than dynoing a big power car.
I feel safer, but not really. Just for fun, let's see what this one has left in it.
All right, here we go.
We'll make the pull from 2,000 to 3,800 and hope we can make it there. This isn't the original 225 engine. It was replaced with a 95 horsepower 1975 model in the 80s, and it's seen a lot of miles since, making this Duster a perfect home for our leaning tower of power. I think we're there. At a whopping 64 miles per hour, it made just over 70 horsepower. And the graph tells the story.
We're not laughing at it, because this was a staple of economical performance back in the day.
You're good on the back.
We can hoist this 225 out of the car to make way for the new Bullet.
It's time to drop it in. Hot dog.
Nice, nice.
I'm good right here.
Coming down.
Look, how's that other side? Oh, something happened.
It's in.
Yes, yes, yes.
At this point, this project is done, and just in time.
That's super cool. I feel like a kid. I feel like a kid at Christmas.
Yeah. We're taking this one to a safe 4,500 RPM. Look at that, 125 horsepower.
Get out of here.
161 foot-pounds of torque.
Wow.
We're not done.
Oh, we're not?
No, we're gonna pull a little more out of it.
Oh, really?
Yeah.
Wow.
Let's make a timing chain. 2 more degrees of initial timing for a total of 6. 129 and 164. Picked up 3 foot-pounds and 4 horsepower.
That's impressive.
One last run with 2 more initial degrees for a total of 8. How you like that? 132, 170.
That is marvelous.
2 degrees picked it up 3 horsepower and 6 foot-pounds.
And you just can't get used to hearing that roar. I see it rolling down the road, just zipping.
And now he can, with almost twice the power he started with. Hats off to Ken for keeping the legend of the Slant-Six alive.
Now, let's hop in the way back machine for an engine that started it all, the Ford Flathead.
A while back, we took a closer look at the engine that launched an entire lifestyle and industry based on power and speed, the Ford Flathead. A simplistic V8 with room for improvement, and it didn't take long to find it. It was then when Edelbrock marketed his first high-performance intake manifold, with a cylinder head soon to follow. And he wasn't alone. Go-fast parts were popping up everywhere. A new purpose for the Flatty was well on its way. We found ours in a junkyard intact. The casting tells it's from the mid-50s, and the rust confirms it. This thing is locked up solid. A short soak freed up some pistons, but the rest put up a battle. The block had been previously bored and appeared solid, but only a trip to a machine shop can confirm it.
Up next, back from the machine shop, we're building power.
We're back, and so is the Flathead, along with legendary engine builder Keith Dorton. He also brought his passion.
You know, they're the coolest sounding engines you've ever heard. They have a unique sound, and they run so smooth, and, you know, in the stock form, they were just as quiet as a Cadillac engine, you know. So it was good to find a block that was in as good a condition as this one is, even though it had some cracks in it that are common with the Flatheads, but this one, about as good as you're gonna find now. All that we had to do at the shop, and it wasn't a must, was we did the relieving the block, which the area between the valves and the cylinder, we dropped it about 80 to 90 thousandths to increase the airflow from the valves to the cylinder, which is part of the combustion chamber.
The first part of the build will be the bottom end. Now a set of Clevite bearings will fill the Flathead's 3 main journals. Now the crankshaft is Scat's 9000 series made for the street and strip. It will give our Flathead 304 cubic inches. Next up are the original main caps. Now they're filled with the other halves of the Clevite bearings. ARP bolts will anchor them in. With ARP's ultra torque on the bolts, we can torque the first 2 caps to 40 foot-pounds. Forcing the crank towards the front of the engine will align the 2 halves of the thrust bearing, which is at the rear. Now torque that cap to 40 foot-pounds. Set up the magnetic base and dial gauge on the crank snout, and with the reading at 0, we'll rock the crank from front to back to check the thrust clearance.
Right at 6.
Which is in spec. Now torque all the caps to the final value of 70 foot-pounds. The Scat rod is held to the Ross forged piston with a floating pin. Now spiral locks will keep it in place. Gapping the rings is a must. Keith is using our Goodson filer to open the gaps, which will avoid them from touching when the engine gets up to temperature, which would lead to a major failure. Vic Edelbrock Sr. designed the first aluminum performance flathead cylinder head back in 1938. Now from that point on, production never ended. Now this is the 49 through 53 version, and it got its name from the thin design. Now underneath, the combustion chamber looks small, but it's actually 65 cc's. They're ribbed internally and externally for strength and have large water jackets for better cooling. Both heads will be torqued in sequence to 60 foot-pounds. And for the final time, here's Edelbrock's vintage tri-power intake setup, and it's not just for show.
I think it's great that you can bolt these carbs on right out of the box and get the results it works. I'm sure we're going to get here. The manifold looks so cool too.
For spark, a Mallory Unilite electronic distributor, a huge leap in technology from the 50s. New high-flow water pumps are next, and these will be the last parts Keith installs for us.
We got to put some fuel lines on it, or you do, because I got to get back and get to work. We've been gone long enough.
Keith did what he came to do, reviving an important piece of history.
Really a fun project to come back and work on something this old. And I'm very confident that we're going to get some good results out of it.
And if Keith says so, so it shall be. Now, as far as a horsepower goal, we're going to let the dyno decide, because we just don't know. Got your seatbelt on and your helmet strap?
I'm ready. Good. Let her rip, Tater Chip.
156, 247. Awesome.
I like it. Let's throw some timing at it and see how it likes it. We'll sneak it up to about 26.
259, 264.
Nice.
That's nice. Nice smooth graph too, and it's still climbing at
There,
42.
yep. No, this is our coolness factor on this one's off the charts.
So it's back to 26 degrees for one last pull. We'll claim victory at 159 horsepower and 257 foot-pounds of torque.
I'm glad I got to be able to help with it. This is ultra cool. It's a great little engine. It looks great. We've built plenty of engines, but the Ford FE was a boneyard to beast favorite. We're back on engine power with a new and, more importantly, damage-free block for the 390 FE build. Before we got started, we examined this block inside and out, and it looks good. Now we can make forward progress on the build, starting with new cam bearings. Next are a set of Speed Pro main bearings, with the clearance set up between 30 and 33 10,000ths. With a fresh rear main seal in place, the bearings are lubed with Permatex Ultra Slick. Then the crankshaft is carefully placed into the block. This is a cast steel piece from Eagle Specialty Products and has a 4,250 stroke. The ARP fasteners are torqued to 100 pound-feet. The camshaft is a custom ground billet hydraulic roller from Comp Cams. The lobes are from their Extreme Marine High Lift series, which increases durability with extended run times. Comp also provided the billet double row timing set. The pistons are Molly's Power Pack series with a 16cc dish. They are mated to a set of Eagle 4340 forged I-beam connecting rods that are 6/700 in length. The included ring package is a modern 1mm, 1mm, 2mm thick set. The rod journal is the same size as a big block Chevy, and the rod bearing clearance is between 23 and 27 10,000ths. The rod bolts are torqued to 90 pound-feet to achieve the correct bolt stretch of 59 to 63 10,000ths. We confirm this with our ARP digital rod bolt stretch gauge. A Melling high-volume oil pump will keep the engine well lubricated. We chose Milodon for the windage tray, oil pickup, and 8-quart oil pan. With the ATI balancer in place, true TDC is set, and the timing pointer is modified to indicate 0.
It's time for this old iron to meet modern airflow and performance thanks to the guys at TrickFlow for designing and bringing to market these FE cylinder heads. They're designed for 390 through 428 engines and are dubbed the PowerPort 175s. Now that's because of the 175cc intake runner. The combustion chamber is heart-shaped and measures in at 70 cc's. The intake valve is 2190 and the exhaust valve is a 1625 diameter. Flow at 600-inch lift is 332 CFM, and these heads are a direct bolt-on for all 61 through 76 FE engines.
We're restricting the oil to the top end of the engine using a 3/8 set screw with a 75 thousandths hole drilled into it. This ensures more oil goes to the main and rod bearings instead of flooding the valve train. 30 thousandths thick Cometic MLS gaskets drop into place, followed by the cylinder heads, which are torqued to 100 pound-feet. Comp retrofit hydraulic roller lifters will move the valve train. Our freshly sandblasted intake splash guard goes in, followed by some beads of Permatex Right Stuff 90-minute gasket maker. The TrickFlow track heat intake manifold is a single plane design that has a basic operating range from 4,000 to 7,000 RPM, perfect for our application. Our engine combination requires custom length push rods, and Trend Performance made it happen with a set of 8/900 long, 80 thousandths wall, 3/8 diameter pieces. No matter what you need, they can handle it. The heavy-duty shaft rocker assembly is from Harland Sharp. It has a 1.76 ratio with a 7/8 inch shaft and full needle bearing construction for high horsepower and endurance builds. Valve lash is set, and this engine is headed to the dyno.
Okay, we've got the 445 cubic inch FE on the dyno. It's running and we're ready to make some pulls. This thing is gonna be a beast. How are you doing the pulls?
We're gonna go 35 to 65 to start out, 30 degrees of timing.
Nice.
You like that?
Love it. Hello, sir.
Look at that.
Hello.
How you feeling now?
Wow.
Woo! 550 pound-feet of torque and 562 the first pull. I got all tingly on that one.
Man.
Now we got to step on some timing. We'll add 2 more degrees of ignition timing for a total of 36 degrees. Give her the gusto.
Pretty healthy FE.
Absolutely. Nice, super clean through the pull.
Liked it. 583, 562.
All right, we're starting to get. We're going to start to get into a threshold
There
here.
it is.
I'm completely fine with stopping here.
This is a stump pulling, I mean, heavy car, heavy truck, anything. I would like to see this go in a truck.
Yeah, me too.
Beautiful.
Nice hustle.
Up next, it's an interesting request for some big bow tie power. It's time for us to start some new projects, and you may be wondering what we're doing over here in the Truck Tech shop. Well, we're teaming up with LT and Austin on their 65 Chevy truck project, and like usual, our assignment is in the engine department.
This is the actual engine that we're building for Truck Tech. We honed it here on our Sun SV15, did some headwork on our MSC industrial machinery, then took it to Shacklet Auto Machine to do a valve job. It was assembled using parts from Summit Racing, Trend Performance, 12bolt.com, and Comp Cams. We had some fun with LT and Austin on the dyno. Here's how that went down.
Yeah, that's where it starts to sound good.
Sounds like an airplane.
Awesome oil pressure, everything. Let's see what we got.
You guys will hate me for saying this, but it almost sounds like a Skyline motor.
You shut your trap.
Wow. So these came from the factory with like what, 165, right? I think
Yeah,
somewhere in there.
160, 165 is what we looked up, you know.
From small 4-bangers to big-inch race engines, turbocharging is an easy way to make efficient and very impressive horsepower. Now, our task today is to outfit that 292 with this turbo system that LT and Austin designed for their project. It has a cast iron turbine housing with a 3-inch V-band outlet, and the turbo has a .88 AR ratio. The rest of the system was designed to be simple and straightforward, eliminating the need to constantly work on it to keep it on the road. It's a driver, not a race rod. With that being said, other components include an air-to-air intercooler, precision wastegate, turbo smart blow-off, and several clamps, pipes, and components to wrap up the plumbing.
One of the main changes that will be happening from the naturally aspirated to the turbo setup is that the carburetor will be going away. We've opted to run one of these new EFI setups that Holly has been developing.
LT did a great job fabricating the hot side for both the NA runs and the turbo install.
Nice going.
It's always a great idea to have an intercooler anytime you're pressurizing air with a turbo because, well, that heats the air up and we want to cool it back down so it has the most capacity to make more power. Colder air is denser. Now, you might look at this and think, well, it's not a very large intercooler, and you'd be correct. But there's 2 reasons that kind of work in our favor. Number 1, we're not going to be pushing this turbo very hard, so it's not going to be generating a ton of heat. And the second reason, well, that's just space. We don't have a ton of room behind the grill and in front of the radiator on our C10 that this 292 is going in, so that's just a fact of life. This is what we have to work with.
We also installed the Turbo Smart Race Port blow-off valve, which on a gas motor, when you let off the accelerator, that throttle plate is going to close, and well, it just relieves that extra boost. That way you're not stalling out that turbo.
Austin and LT just wrapped up installing the cold side on their 292, and I gotta say, it looks pretty impressive. Now it's our turn to go ahead and put in all of our new notes for the turbo system and get the dyno all up and running so we can make some pulls. And before we do that, Pat's got something to tell you about in the dyno room.
Having the Sniper X-Flow EFI run on a naturally aspirated versus a turbo is simply telling it what it's on. If you go into the initial setup wizard, you can actually choose turbocharger, nitrous oxide, supercharger, or from naturally aspirated, and that tells the unit what it's on. Now, that will give you a couple of options of retarding your timing per boost level and also adjusting your air-fuel ratios for boost level. It's pretty slick.
All right, LT and Austin are wrapped up and it looks really good. Now it's our turn to make some noise, as LT would say. Now they had to run out and go do something else, so we're gonna continue with the dyno poles. Now right now we have the natural and the red spring in the wastegate for a total of 7.5 PSI of boost. Pat's gonna go ahead and make the pole and see how this thing ends up.
Hit the red button.
Man,
Look at that.
Man, that's not bad.
What do we want to do with spring?
We go with the natural and the green spring. That'll go from 7.5 to 10.5. That's a 3-pound increase.
I'll buy that.
All right. Wow! Holy cow!
510. Now I kind of ramped it in there. 376 horsepower. I'm definitely happy. Man, this is a win. This is absolutely a win.
Good job.
I love history and I love engines. So hopefully this will inspire you to rethink your next project build.
That's right. And if you're interested in anything that you've seen on today's show, hop on over to PowerNationTV.com for more.